So we're going to look at trigonometric equations today, but first I wanted to go back and just mention a few things that I'm just touching upon. This is not on your final, but I do want you, and it's not on your quiz, but I do want you to see it. At some point, this is something that you should be looking at on your own, okay? So the first thing is we talked about right triangle trigonometry, and I touched upon this idea that you can you could figure out these missing sides and these missing angles for triangles that aren't right triangles. So if we take an example, okay, just any old triangle, and we say that this side is 12, this is 32 degrees, and this side is 15. And we want to find this side. Now we cannot use the Pythagorean theorem because the Pythagorean theorem only applies to right triangles. So we have to use something else, okay? And in this particular case, we can use something called the law of cosines. So the law of cosines uses three sides and an angle, okay? And it says that c squared is equal to a squared plus b squared minus 2ab times the cosine of c, okay? If you notice, this side is opposite this angle. So if you remember, we talked about the way that we labeled triangles, and we said that we label triangles so that the angles are uppercase letters and the sides are lowercase letters, and the lowercase letter is the side that is opposite the angle with the same uppercase letter. So for example, this would be side C because this is what we're looking for, and this would be angle C. So in order to find side C, we have to know the angle that's opposite it because that's what we use in our formula, okay? So in order to find this side, we have to know the angle that's opposite. Okay, you can see that in the formula here. And the way that you would prove this formula, which we're not going to take the time to do, but if you ever want to know, I can, obviously just email me. We also need to know the other two sides, right? The other two sides are in here. So this is what you would use if you have an arrangement like this, where you have two sides, and we call this the included angle. And it's just a plug and chug, okay? It's just c squared is going to equal 12 squared plus 15 squared. It doesn't matter which side is A and which side is B. It makes no difference here. So we have 15 squared, and then minus 2 times 12 times 15 times the cosine of 32 degrees. Okay, so it's simply plug and chug, but you have to, in terms of what you know, it's got to be in this arrangement where you have two sides and you have the included angle, and then the opposite side is the one that you're trying to find. So that would be the law of cosines. Now, we can also have, right, sometimes this is not the arrangement that you're given as what you know. So sometimes we're given a triangle where we know different things. So let's say, for example, we know this side, and we say that this side is 8. We know this angle. This angle is, let's say, 18 degrees. This is the angle that we're looking for. So this time, let's say that we're looking for an angle. I'm going to make this triangle a little bit bigger because you can't really see it. So this is 8. This is theta. This is 18 degrees, not drawn to scale. And this is what we're trying to find. So we know a pair that's opposite. Sorry, we're trying to find the angle. This is, let's make this 6. Okay, so we know a pair where we know the side and the angle opposite it. And then we have another pair where you have one unknown, okay? So here we know the side, we're looking for the angle. If we had known this side, then you would be using the law of cosines, okay? But here, we use something called the law of sines. So in the law of cosines, you can know all 3 sides and be looking for an angle. Or you can know 2 sides and the angle included, okay, the included angle, which is the angle between those 2 sides. For the law of sines, it's different information that you would know. People write this differently. I tend to write it as sine A over A equals sine B over B, which is equal to sine C over C. So you're only using 2 of these at any given time. So depending on what you're looking for and how you label your triangle, you might be using sine A over A equals sine B over B. Or you could be using sine B over B equals sine C over C. Or you could be using sine A over A equals sine C over C. And sometimes you'll see it, some people will write it where the sides of the triangle are the numerators and then the sines of the angles are the denominators. It doesn't matter, okay? Ultimately, it doesn't make a difference as long as you're consistent. Let's label this triangle. And again, it doesn't matter the way that you label it as long as if you have an A here to label the angle, then the side opposite is the lowercase a. So if we say that this is A, then this side has to be side A. If this is side B, if that's angle B, if this is angle B, then this has to be side B. And if this is angle C, then this is side C. So we know we're looking for angle A, we know side A. And we know side C and angle C. So we can use law of sines. Notice we would not be able to use law of cosines, because law of cosines, we either need to know all 3 sides or we need to know 2 sides, and the angle that we know has to be the angle in between, okay? Here, or we can know, right, I gave you all of the possibilities already, I forgot. For the law of sines, you have to have pairs, right? And you're going to know if you're using the wrong one because you won't be able to plug into this formula, okay? And again, we can derive it. You derive it using right triangle trigonometry because every triangle could be redrawn as right triangles. So like for instance, we could cut this with a perpendicular line. So this would be a plug and chug also, right? So it would be sine of theta over 6 is equal to sine of 18 degrees over 8. And we could just, cross multiply, and a cross multiplication is multiplying everything by 8, and then multiplying everything by 6 on both sides of the equation. So we could cross multiply and solve for sine of theta. Remember, when you're solving for an angle, you are going to have to take the inverse of sine of theta. You're going to have to take the inverse of both sides at some point. Okay, but this is the way that you would solve for missing sides or missing angles in a triangle that is not a right triangle. This is not going to be on your quiz. It is not going to be on your final, but I do want you to become familiar with it because you will be using it in calculus. Okay. The second thing that I wanted to show you is that there are other identities. Okay. So the other identities that we have are like half angle identities. What does this mean? It means we can express or find the sine of 30 degrees using 60 degrees. Okay, or if we use radians, the sine of pi over 6 using what we know about pi over 3. We have double angle identities. We have sum and difference identities where we can find the sine or cosine of an angle using two angles that we already know. So for example, if we want to find 60 degrees, we might use 30 plus 30. If we want to find let's say 75 degrees, we can use 45 and 30 degrees. So we can use sums and differences of angles that we know. And when I say angles that we know, what I mean is that angles that we know the exact values of. So these would be the other identities. Okay, so we have sum and difference identities. These are the ones that we talked about. Okay, our cofunction identities is the sine of an angle is equal to the cosine of its complement. These are the ones that we sort of talked about already, but these are the other identities that you could be using. Okay, so the sine of 75 degrees, you can use the sine of 15, the sine of 30 and the cosine of 45 plus the cosine of 30 times the sine of 45. So you can use these. We're not spending time on this, but before you go into calculus, okay, you must become familiar with these. You should be looking at them, plugging in, seeing how they work, becoming more familiar with these identities so that when you go into calculus, you are more familiar with it. You can plug in values. You can find exact values. So these are all plug and chug. We can prove them. We can derive them. I'm just not taking the time. The semester ended. But you can, these are what the identities look like. And I will post these with the trigonometry lectures so that you have them. But again, they're not going to be on your final or on your quiz, but this is something that you should concentrate on before the next semester. Okay. Okay. So equations, trigonometric equations. The nice thing about trigonometric equations is they're very much like everything that we've done so far. We've solved equations. The way that you solve equations is no different when they're trigonometric, okay? What changes is really how you express your answer, because your answer is in angles. Now, I'm going to go back to that exact value chart. I'm going to put it in here again, even though we've written it in our notes twice. I'm going to review it with you one more time. And what I want you to concentrate on is the angles and radians, because we're going to be working with both, but you really have to become familiar with these radians, okay? And a lot of the problems that we're going to do are going to be using the radians instead of the degrees. Now, I want you to know, if you're very uncomfortable, you can always express your angle in degrees and then convert it to radians, but that's extremely inefficient, okay? So our exact value chart, we have your 0 degrees, your 30 degrees, 45, 60, and 90. Now, if you're using the pattern to create this exact value chart, you have to realize that these angles have to be in increasing order, and you have to remember that there are 5 of them, okay? So, because if you forget that there are 5, then your pattern is going to fall apart. Now, 0 degrees easily is 0 radians. That's easy to remember. And then these other angles, remember that 180 degrees is pi. So what's 30 degrees? Well, that's pi over 6, right? 180 over 6 is 30. 180 over 4 is 45. 180 over 180 over 3 is 60. And notice 180 divided by 60 is 3, right? 180 divided by 60 gives us our 3, so it gives us our denominator. And then 180 over 90 is 180. It gives us pi over 2. 180 over 90 is 2. Or 180 over 2 is 90. Okay, so that gives you your angles and radians. Become very familiar with this. Okay, make flashcards if you have to, but you should be very familiar with these angles. Okay, and like I said, most trigonometric formulas, most formulas that come with like area of a circle, they're much simpler. Okay, if we take area of a part of a circle, those formulas are much, much simpler if you're working in radians versus degrees. Okay. Then in this chart, we're looking at sine, cosine, and tangent. Remember, if you know the sine of an angle, you also know the cosecant because it's the reciprocal. If you know the cosine, you also know the secant. And if you know the tangent, you also know the cotangent, okay? Because those are all just reciprocals. The sine of 0, remember that can come from the unit circle. You can also remember this using those triangles that I showed you in a previous lecture. But if you remember all of these, I'll put it in a different color so that it's really clear what your answers are. All of your denominators are 2. I'm leaving a little bit of room so that we can write the simplified version as well. And remember, if you know all of your sines, then you know all of your cosines, because the sine of an angle is equal to the cosine of its complement. So you don't have to remember this whole table. If you know your sines and your cosines, you don't need to know your tangents, because tangent is sine over cosine. So you don't have to remember the whole table. If you remember just the sines of every angle, then you know you can figure out everything else. Okay. So our pattern is for sine, it's 0, 1, 2, 3, 4, and then you take the square roots. Okay. For cosine, it's the opposite. It's 4, 3, 2, 1, 0. And then for tangent, Again, we have all fractions here. They're ratios, right, of the sides of a right triangle, so it makes sense that we have fractions. And it's sine over cosine. So those 2's in the denominator cancel out. And here we have 0, 1, 2, 3, 4, all square roots. And then we have 4, 3, 2, 1, 0, all square roots. Okay. If we simplify as much as possible, again, I'll use a different color. This is just going to be 0. Square root of 0 is 0, and 0 over anything is 0. This is going to be 1/2. Square root of 2 over 2 cannot be simplified, and neither can square root of 3 over 2. But square root of 4 over 2, square root of 4 is 2, so 2 over 2 is 1. And this 0 and 1 makes sense, right? At 0 degrees or 0 radians on the unit circle, the y value is 0. At 90 degrees or pi over 2 on the unit circle, the y value is 1. So this makes sense, okay? And then we're looking at the x values. The x value at 0 degrees and 0 radians is 1, okay? And the x value in 90 degrees or pi over 2 is 0. The sine of the angle is equal to the cosine of its complement. Square root of 3 over 2 can't be simplified. Neither can square root of 2 over 2, but square root of 1 over 2 is 1/2. Square root of 0 over square root of 4 is 0. Square root of 0 is 0. Anything over 0 is 0 over anything is 0. This is 1 over square root of 3, but when you rationalize your denominator, it becomes square root of 3 over 3. Square root of 2 over square root of 2 is 1. Anything over itself is 1. Square root of 3 over square root of 1 is just square root of 3. Square root of 1 is 1, so square root of 3 over 1 is square root of 3. And square root of 4 over square root of 0, well, this is undefined because you can't divide by 0. Okay, so you should be able to put it in its simplest form. You don't have to start off with it in its simplest form. So if you're remembering the sine of 30 as square root of 1 over 2, that's fine. Then put it in your simplest form, okay? So how you remember it, it doesn't matter. Now, obviously, on your final, it's more like a take-home, so you don't have to memorize this. But I will warn you, you go into a calculus class and you don't know the sine of 30 off the top of your head, it's going to be a problem, okay? Okay, so let's start solving equations and seeing how we use this, okay? Now remember, 0, 30, 45, 60, and 90 are all reference angles, okay? So these are all reference angles, and we're going to be using them as reference angle. And the way that we're going to learn to solve equations is we're just going to solve a bunch of them. So let's take the sine of x plus the square root of 2 is equal to negative sine of x. Okay, this is going to be our first equation to solve. Okay, and I want you to remember that, and we talked about this a lot, there's not only one angle where the sine is 1/2, right? 30 degrees, the sine is 1/2, but there are other angles that have a sine of 1/2. Specifically, the sine of 150 degrees is 1/2 because the reference angle for 150 degrees is 1/2. So we're going to find all of the angles for which we solve the equation, okay, for which the equation holds true. So how do we solve this? Well, the idea is that we solve for x, okay? We are solving for our variable. And I think in all of these examples, we're going to use x. So I'm going to say solve for the unknown, but in these cases, okay, so it might be x. It might be theta, or it might be something else altogether, but it's whatever your unknown is. Okay. So how do we do this? We do it in exactly the same way that we solve for anything else. We isolate our trig function, okay? So how do we isolate the trig function? We are going to add the sine of x to both sides, okay? Or subtract the sine of x from both sides. We want our variables on one side, we want our trig function on one side, and we want our numerical values, our constants, on the other. So just like we would isolate the absolute value, we would isolate the square root, we would isolate the exponential function, we isolate the trig function. So the fastest way to do this in this case is subtract the sine of x from both sides. Okay, now on this side it's going to cancel. Sine of x minus sine of x is 0. But be careful. Here we get square root of 2 is equal to negative 2 sine x. Okay, negative 1 minus 1 is negative 2. Be careful there. Okay, so now what? Well, again, we still isolate. So now we divide both sides by negative 2. Okay, the negative 2 will cancel here. And what are we left with? We are left with sine of x is equal to negative square root of 2 over 2. Okay, we've isolated the trig function. Now what? Well, now we have to find x. We found the sine of x. We found that the sine of x is equal to negative root 2 over 2. But there are two answers here, okay? Because we have two angles where we have negative root 2 over 2. Two angles that have the same sign, okay? Remember, the unit circle is symmetrical. So we have our circle. Remember, at any given point, you have two points that have the same y value. You have 2 points with the same x value. Okay, so 2 points with the same y value, the same sign. So we have to figure out what both of those points are. So square root of 2 over 2, you have to figure out what the reference angle is, because that's going to tell you what the sign is. We know that the sine of any angle is the same as the sine of its reference angle. It might be positive or negative, okay, but it's the same value. No apostrophe. So depending on what quadrant we are in, it might be negative, right? So here, what you're going to do is the next thing that you're going to do is you're going to identify what the reference angle is. Okay, so sometimes I'm going to tell you do it in degrees, and sometimes I'm going to tell you to do it in radians. So this one we're going to do in radians, and typically in the next problems, I'm going to tell you, okay? So in this one, we're going to do in radians. And we're going to get even more specific in a few minutes, okay, where we give you the domain. Okay, this is where your exact value chart becomes important, because what you're doing is you're saying, okay, which angle has a sine that's equal to the square root of 2 over 2? Don't worry about the negative yet, okay? Don't worry about the negative. Well, let's actually... Before we identify, I realized that it makes more sense to do it the other way. Instead of identifying the reference angle first, identify which quadrant you're in. You can do this in either order, but it kind of makes sense to do this first. So identify the quadrant you're in. What do we mean? The sign is negative. In which quadrants is the sign negative? So the sign is negative in quadrants 3 and quadrants 4. So based on whether your trig function is positive or negative, so in quadrant 3 and quadrant 4, this is where sine is negative. Now you're going to identify your reference angle. Okay, so what's our reference angle here? Our reference angle, well, we're looking for an angle where the sine is square root of 2 over 2. That's pi over 4. So that's our reference angle. Okay, so how do we find the angle in quadrant 3? Well, in quadrant 3, this is a little bit different, right? In order to find the reference angle, if we have an angle in quadrant 3, we would do the angle minus 180 degrees, but that's not the case here, okay? What we're doing is we're trying to say, okay, we start from here. We know that this is pi over 4. So how do we find the angle that goes from here to here? Well, we know that this piece is pi over 4, and what do? We already went half a circle, so we have to add in pi over pi. So this says x is equal to pi plus pi over 4. And this one says, okay, well, we want to go all the way around. Well, it's 2 pi minus pi over 4. And we're going to do a lot of these. Okay, now I'm going to give you the answer here, but we're going to discuss it on the next page. So pi plus pi over 4 is 5 pi over 4. And we'll get to that. I kind of ran out of room here. This is 7 pi over 4. But let's talk about that, okay? So our answers are 5 pi over 4 and 7 pi over 4. These are our answers. Okay, so let's talk about this a little bit more. We have a reference angle here where this is pi over 4. Now we need to know, not the reference angle, we need to know what the actual angle is. We need to know this. So the question is, how do we find this? So this angle is pi over 4, but we need to start from here. So how do we do that? Well, from here all the way around, this is pi over here, right? This is pi. So what are we doing? We're walking a distance of pi, and then we're going an additional pi over 4. So this angle in quadrant 3 we're doing pi plus pi over 4, or pi plus our angle, whatever our reference angle is, it's pi plus our reference angle. Okay, so pi plus pi over 4, we got 5 pi over 4. So how did we do that? Well, we needed a common denominator. This is like pi over 1. So if we needed a common denominator, we needed the denominator of the first fraction to be 4. So we multiplied by 4 over 4, which gave us 4 pi over 4 plus pi over 4. And that's how we got the 5 pi over 4 on the other side. Okay, let's look at quadrant 4. So in quadrant 4, again, we had a reference angle of pi over 4. But we don't want the reference angle. What we want here is this angle. We want the opposite, okay? So if we want the opposite, what's in pink, what we're really doing is we're saying, let's go around the whole circle, but we're going to go pi over 4 less than the whole circle. So we're going to go in quadrant 4, we're going to go 2 pi minus pi over 4. What that'll do is it'll say, okay, let's delete this. Let's erase this. And that's going to give us this angle here. Okay. Now we said that that gives us 7 pi over 4. So how does that happen? It happens in the same way that it did over here. Okay. 2 pi is really 2 pi over 1. So we need a common denominator. Okay. What that does is it gives us 8 pi over 4 minus pi over 4. Well, what's 8 pi minus pi? 8 pi minus pi is just 7 pi. So that's how we got those two answers. And note that in quadrant 4, what we're doing is we're doing 2 pi minus our reference angle. Okay, and that's how we would do it every time that we're trying to find an angle in quadrant 3, or any time that we're trying to find an angle in quadrant 4. In quadrant 3, we would do pi plus our reference angle because we're going pi and then plus the extra piece. And in quadrant 4, we would go 2 pi and then subtract that extra piece, subtract that reference angle. So we're not going quite all the way around the circle. We're going all the way around the circle minus the reference angle. Okay, and what does that mean for the other two? So if our angles if our angles were in quadrant 1 or quadrant 2, let's just take a look at that. So quadrant 1, that's so crooked. That's better. Okay. If our angle were in quadrant 1, here's our angle, then it's easy, right? In quadrant 1, it's just our reference angle. But if our angle were in quadrant 2, here's our reference angle. Okay, if that's our reference angle, we're not looking for that, right? We're looking for the angle coming from here. And if we're looking for the angle coming from there, well, we're not quite going pi, right? We're going pi minus our reference angle. We're going less than pi. So keep in mind, how do you remember which is which? Well, first of all, draw a diagram. That will help, okay? Second, we're only using pi or 2 pi, okay? If it's not just the reference angle like it is in quadrant 1, we only use pi or 2 pi. Notice we never use our y-axis, ever. Same thing for finding the reference angle. This is saying find the angle given the reference angle, okay? So for this, it's either going to be pi plus if you're in quadrant 3 because you're going further than pi, or pi minus if you're in quadrant 2 because you're not going as far as pi. You're going less than pi, And then for quadrant 4, you're not going as far as 2 pi, you're going less than 2 pi, so it's 2 pi minus, okay? And this is just to help you find the angles. Once you find the reference angle, then you can find the actual angle. So that would be your step 4. You're finding your actual answer. Okay, and I'm going to put in here, pay attention to the domain. Right now, in this problem, don't worry about it. In future problems, we will. Okay, pay attention to the domain. So in this one, I'm going to say, don't worry about this for this problem though. The domain, we're going to say, is in the interval 0 to 2 pi. Okay. So in other words, we're just going around the circle once. We're not going around the circle an infinite number of times. Okay. Let's do another problem. Let's say, for example, we do sine of x. So we're going to find x in the interval 0 to 2 pi. So we're going to do radians again. Okay. If it said 0 to 360, the only thing that would change is that instead of seeing pi here, you would do 180. Okay. And instead of using 2 pi, you would use 360. Instead of using pi here, you would use 180. And instead of saying that your answer is pi over 4 as your reference angle, you would say that your reference angle is 45 degrees. Okay, so you would just be using degrees instead of radians. Okay, find x in the interval 0 to 2 pi. So this is telling you that your answer is in radians. For similar problem, sine of x minus square root of 2 equals negative sine x. Okay, very similar problem. So once again, same process, okay? We're going to isolate our trig function. So this part is straightforward. This part is the stuff that you've done over and over again. It's that very last part where you're finding your x after you've isolated the trig function. That's the new part, okay? So we can subtract sine x from both sides. Okay, this is not the only way to solve, right? Some of you I know would add sine x to both sides. Just be careful however you do it, okay? But I'm just going to do it this way where we get, where I move the sine x so that it's on one side, the constant so that it's on the other side. So if you do it differently, that's fine. I know ultimately you get the same answer. So what do we get here? We get negative root 2 is equal to negative 2 sine x. Now we're dividing both sides by negative 2. And the difference is that your answer, your sine of x here, is now a positive number. Okay, so at this point, we've isolated our trig function. Okay, So the next thing that we're going to do is we're going to identify which quadrants are we in. So in the last problem, we kind of broke it all up, which might have you might have lost your train of thought somewhere in there. Here, we're just going through the problem step by step, so it'll be easier for you to follow. Okay, so our first step was we isolated the trig function. Our next step is to identify the quadrants. So what are we doing? In this case, we're looking for quadrants where sign is positive. How do we know that sign is positive? Well, we look at our answer, and our answer tells us sign is positive. So which quadrants are we in? Well, sign is positive in quadrants 1 and 2. That's where our y values are positive. So we're going to have answers in each of these quadrants. What's our next step? Our next step is to figure out our reference angle. Well, that's where we go back to our exact value chart. And you should know in your exact value chart where you are, okay? You should not have to go back and look at it. So we're going to identify our reference angle. Now we are in radians because we look at 0, 2 pi. We look at the interval and it tells us that we're in radians, okay? Because we have 2 pi. We're going from 0 to 2 pi, not 0 to 360, okay? So we're saying what angle has a sine of square root of 2 over 2? Well, it's pi over 4. Okay, that's our reference angle. So what angle has a reference angle of pi over 4 in quadrant 1? Well, quadrant 1, the reference angle is the angle itself, right? Reference angle is the angle itself. So in quadrant 1, x is equal to pi over 4. What's the angle in quadrant 2? Well, in quadrant 2, again, your reference angle is this angle here, okay? So we want to know, well, what's this angle in pink? What's the angle if we start at the positive x-axis and then go to our terminal side? Well, that's pi minus pi over 4. And if we multiply by 4 over 4, this is the same thing as 4 pi over 4 minus pi over 4. Or 3 pi over 4. So these are our answers here. Okay, and once again, the 0 to 2 pi, the 2 pi is what tells us answer should be in radians. Okay, so let's talk about this interval for a second, okay? So what the interval says is that we're going around the circle once, okay? Now, there's a bracket before the 0 because you're including 0 radians. Now, you're not including 2 pi radians, and the reason why you're not including 2 pi radians is because 0 and 2 pi give you the same answer, right? You're right back where you were when you're at 2 pi. You don't want to repeat, okay? So there's a parentheses here because, okay, because 0 and 2 pi are the same and you don't want any repetition, okay? So the first thing is 0 to 2 pi says your answer should be in radians. And you're only looking at one rotation around the circle. Now the same thing is true if you went from 0 to 360. Okay. This says your answer should be in degrees. And you are looking at one rotation around the circle.